Students, welcome in physics classes. The topic which we are going to start is Gauss theorem. It is very important topic for CBSE school students, that is Gauss theorem. So first of all, let us know what is statement of Gauss theorem. Always remember, Gauss theorem states that electric flux passing through a closed surface enclosing some volume. Please stress on this line, enclosing some volume, because we have to consider only what three-dimensional figures. Figure in space, not a circle, not a square. We shall always take a three-dimensional figure which contains some volume. That's why we can say total electric flux passing through a closed surface enclosing some volume is equal to 1 upon epsilon naught times the charge enclosed by the surface. That's why Q is the charge enclosed by the surface, phi is the flux passing out through the surface, then phi is equal to 1 upon epsilon naught Q. In previous lecture, I have taught that electric flux equals to integral E vector dot ds vector. So substitute for phi integral E vector dot ds vector 1 upon epsilon naught q. Gauss theorem therefore can be stated as surface integral of electric field is equal to 1 upon epsilon naught times the charge enclosed by the closed surface. So in either of the two, you can state Gauss theorem. Now we are coming to the topic, what is the proof? How we shall prove Gauss theorem? Students, to prove Gauss theorem, we consider a spherical surface. Charge Q is placed at its center O. R is the radius of the surface. R is the radius of the surface. And on the surface of this sphere, we consider a point P. On the surface of the sphere, we have considered a point P. Surrounding it, there is area, a small area, ds. So how much flux will pass through this area ds? We know flux is given by d phi is equal to E vector dot ds vector, or it is equal to E ds cos theta. What is theta? Theta is the angle between E vector and ds vector, that is electric field and area. For a spherical surface, remember that electric field and area are always parallel to each other. They point in the same direction. Since they point in the same direction, we can say theta is equal to what? G. If theta is equal to 0, then cos 0 will become equal to what? 1. Also, electric field due to a point charge at distance r is given by the formula E is equal to 1 upon 4 pi epsilon naught q upon r square. D phi is equal to, in this equation, I have substituted the value of E. ds cos theta, theta is 0. E is replaced by this expression and theta is written 0. Cos 0, 1. So it remains 1 upon 4 pi epsilon naught q upon r square. Electric flux through the closed surface, this d phi, we have calculated to pass through a very small area ds. We have to calculate the electric flux through the whole surface. That's why I shall integrate it. Phi is equal to integral d phi. When you will integrate, you find that this term is constant, this term is constant. So I have taken out. We cannot do its integration. Constant cannot be integrated. Integral ds. What is integral ds? Integral ds is the area of the surface, a spherical surface. That is 4 pi r square. It cancels out. Flux is equal to q upon epsilon naught. It proves your Gauss theorem. Now one more thing, students. Suppose the charge is placed, if charge is placed in dielectric medium. Students, charge is placed in dielectric medium. Charge is placed in dielectric medium of dielectric constant K. Then phi is equal to 1 upon K Q upon epsilon naught. Then electric flux, Gauss theorem becomes phi is equal to 1 upon K Q upon epsilon naught. Second point, suppose this is a surface and this surface carries charges Q1, Q2, Q3. We know charge is additive in nature. Therefore, what is Q? Q is equal to Q1, Q2 plus Q3. Or you can write summation of Qi, I is equal to 1 to n. Therefore, phi is equal to 1 upon epsilon naught of Q. That is 1 upon epsilon naught summation I is equal to 1 to n into what? So if more than one charge is present within the Gaussian surface, we shall take the sum of all the charges. Remember, when you are going to take the sum of the charges, you will take the sum with sign. Suppose one charge is 2 microcoulomb, another charge is 3 microcoulomb, and the next charge is minus 1 microcoulomb. So what is the total charge? 2 plus 3 minus 1. The result Q will be equal to 4 microcoulomb. So in this way, you can calculate the flux passing through a closed surface using Gauss theorem.